All right, so welcome back to part 2 of transformations. And we're talking in this section about reflection. Reflection is a transformation in which a figure flips over a line called the line of reflection. And in this example, they're using the y-axis as the line of reflection. A reflection creates a mirror image of the original figure. So we have, this is the original figure right here, K, L, M, N. And then you can see this figure in red is still K, L, M, N, but they put these little marks by the letters. That's to distinguish the original point from the reflected point. So what do we call those little marks? So there were transformations. We were talking about transformers. Here's Optimus Prime, because these little marks mean prime. Okay, kind of like the other day when we had that question that had D1 and D2. They just used D1 and D2 as distance 1 and distance 2 to kind of keep them separate. So that's all that means, is that this isn't K, it's K prime. It's the new location of K. So we would read the statement K prime, L prime, M prime, N prime, which is these 4 points right here, is a reflection of K, L, M, N over the y-axis. So the y-axis was our line of reflection. And think about a reflection. Do you remember these art projects that you did when you were really little, where you'd take the paper and you'd fold it and open it back up so you had that crease in the middle, and then you put paint on one side and fold the paper back so that the paint smushes onto the other side, and then when you peel it open you have a reflection. This fold down the middle was your line of reflection. Okay? Had to sneak the rainbow in, right? All right, so let's take a look at the first example here. And in this example, they're asking us to reflect the rectangle over the y-axis. So that means that for this question, the y-axis, if I can draw a straight line here. Oh, that was nice, like how it straightened it back up for me. The y-axis is going to be our line of reflection for this example. And that could change. Okay. So let's take this first point right here. And you see how this point is 2 units away from the line of reflection? We need it to reflect to the other side. And we need it to still be the same distance away. So it's 2 units from the line of reflection on the left side. We're going to move it over here so that it's 2 units from the line of reflection on the other side. Then we'll do the same thing with this point. This point is 4 units from the line of reflection. 1, 2, 3, 4. So we need to move its new point 4 units on the other side of the line of reflection. 1, 2, 3, 4. And we'll do the same thing with this point. We'll move it. It's 2 units from the line of reflection, so we'll put it on the other side of the line of reflection, 2 units away. And then the last point is 2, 3, 4 units, so we're going to move it 1, 2, 3, 4 units to the other side of the line of reflection. And now we look at the 4 points we created, our prime points. And you can see that they look like they're exactly the same as the other rectangles. So their 2 rectangles are going to be congruent. So we just go ahead and connect those. Sorry about that. A little trouble with the Mobi for a minute. All right, so you go ahead and connect those points. And let me fix that one a little bit. There we go. Okay, So you can see that the two rectangles are exactly the same, it's just that this one's on this side and that one's on the other side. They're both 2 units away from the line of reflection. So that was kind of an easy problem. Let's take a look at one that's just a little bit trickier. What makes this one tricky is that they're going to ask us to reflect the triangle over the x-axis. And if you look, the x-axis cuts right through the middle of the triangle. So if you weren't looking carefully, you might have just thought, oh, I'm going to flip it from this side over to the other side. And you would have totally messed this question up. So be really careful. The x-axis is our line of reflection, and it cuts right through this triangle. So what does that mean? Where's it going to reflect to? It's actually going to reflect right over on top of itself. So if you see this little triangle that's up here on the top, color it in for a second. Okay, this little triangle right here is going to flip so that it's down here underneath. Let me erase that. And you see this trapezoid shape that's down here on the bottom? That trapezoid is going to flip above the line of reflection, so it's going to be up here. So let's take a look at what this does. We're just going to take each point, and just like we did on the last example, now this point is 2 units from the line of reflection. Okay, be careful. We're going this way now. So it's 2 units above the line of reflection. I need to put the new point 2 units below the line of reflection. And we've got another point of the triangle right here. This point is 2 units below the line of reflection. So we need to put the new point 2 units above the line of reflection. The same thing with the last point. It's 2 units below the line of reflection. So we're going to place the new point 2 units above the line of reflection. This looks a little messy because we've got points on top of the shape we already have. But when we connect the dots, you can see that we had what we would probably call a right side up triangle before. And now we have an upside down triangle. Of course, obviously they're both triangles no matter what way they're facing. And you can see that little triangle that was on the top has reflected down below like we talked about. And the trapezoid shape has reflected up above the x-axis. All right, so that's it for reflections. And come on back for part 3, rotations.